Welcome to part 2 of the Maker Lessons Ohm's Law series on resistance. The unit for resistance is an ohm, named after George Ohm. Ohm was a German physicist and mathematician. While working as a school teacher, Ohm began his research with the new electrochemical cell, the voltaic pile, invented by Italian scientist Alessandro Volta, which we covered in our last video. Through experiments using equipment he had invented, Ohm found the resistance between 2 points of a conductor when a single volt is applied to these 2 points and current equals 1 amp can be measured and is proportional to a constant value. We call this discovery Ohm's Law, and for his discovery, we named the resistance value after him. The name of electrical resistance is an ohm and annotated with the Greek letter omega. Resistance is defined as the opposition to current flow. All materials except for superconductors have resistance. The value of this resistance is determined by two factors: the material of the conductor and its length, and the cross-sectional area of that conductor. When describing electricity, a common analogy is a water tank with flowing pipes from it. In this analogy for resistance, the material of the conductor and its length is equal to if there is a clog in the pipe and what that clog is made from, while the cross-sectional area of the conductor is equal to the diameter of the pipe. Here's a scenario where the water is being blocked from freely flowing by a sponge. Because sponges are porous, this allows some water to pass through. However, when the water is being blocked by a rock, this causes a more serious clog. Rocks are dense and impermeable, so this clog barely allows water to flow. In reality, a clog could be so bad that it completely blocks the water from flowing. This can also be the case with electric current flow as well. If the resistance from the material or length of material is too high, it will completely block current flow. It also stands to reason that we can't fit as much volume through a narrow pipe as a wider one at the same pressure. This is resistance. The narrow pipe resists the flow of water even though the water is at the same pressure as the tank with the wider pipe. Assuming the conductors are made out of the exact same material, we can see how the diameter of the conductor physically limits the flow of electrons. In the example using the pipes, a bigger pipe can literally fit and allow more electrons to flow at a time than a smaller pipe. This is the same for a conductor. The bigger the cross-section of the material, the more electrons can fit and flow through a certain point. We measure resistance using an ohm meter or a multimeter. These tools pass a steady voltage through the test leads and read the current internally. This allows for the meter to calculate and display a resistance using Ohm's law. We can remember that different materials have a unique conductivity. The more conductive something is, the less resistance that material has. You can see that the resistance of the metal nail is lower than the plastic bottle because metal is more conductive than plastic. While working on electronics, we usually use a component with more reliability and consistency of resistance than a plastic bottle or nail. We call these resistors. Resistors come in all different shapes and sizes depending on the application, but in beginner electronics it is common to use a through-hole resistor. These resistors are built to have very specific resistance values, which are represented by a color band system on each one. Most of these resistors will have 4 bands of color circling the resistor, but some will have 5 or 6. On a 4-band resistor, the first 2 bands indicate the significant digits of the resistor's value. The third band is a weight value, which multiplies the 2 significant digits by a power of 10, and the final band indicates the tolerance of the resistor. The tolerance explains how much more or less the actual resistance of the resistor is compared to what the nominal value is. No resistor is made to perfection. A very common resistor in beginner electronics is 470 ohms. The resistor looks like this. We can confirm that this is a 470 ohm resistor by reading the color codes. Remember, the first 2 bands are the significant digits of the resistor value. Looking at the chart, we can see that yellow is 4 and purple is 7. The third band is our multiplier, and in this example it is brown, which represents 10 to the first power. Without the need to do any math, the simplest way to use this band is to just add the same number of zeros to the significant figures as the exponent on the multiplier. The final band is our tolerance. From our chart, we can see that gold means plus or minus 5%, so this resistor is 470 ohms plus or minus 5% of the value from the tolerance of manufacturing it. We can confirm the reading of the resistor color codes by measuring them with our multimeter. When measuring a single load or resistor, the measurement that we should see is simply the value of the resistor plus or minus its tolerance. This is a 470 ohm through-hole resistor, and you can see it measures the same. When measuring resistance, it is also good to have a basic understanding of how resistances can add up. However, there are different rules for adding resistance depending on what type of circuit you are actually measuring. In this example, there are two 470 ohm through-hole resistors in series with each other. One directly feeds into the other. This would be the same as doubling the length of the pipe in our water analogy. You can see the resistance measured is doubled. In the following example, there are two 470 ohm through-hole resistors in parallel with each other. Both ends of one are connected to both ends of the other. Since there are two paths that the voltage from the multimeter can go, the total resistance is actually less than either individual resistance. This is called diminishing resistance. Details on why this happens will be in a follow-up video. However, this would be like adding a second pipe to our water analogy. You can see the resistance measured on the multimeter is less. Here are some experiments you could try at home. The graphite in your pencil is made from a mixture of carbon and clay. The proportion of those two is actually how they label the softness of each pencil. For instance, a number 2 pencil. The ratio of carbon and clay will change the resistance of the material. This is actually the same material that is used in some of our resistors. If you scratch a dark, thick line on paper using your pencil, you can test the resistance of the line with a multimeter. Change the thickness and length of the line for different resistances. This is the same as if you were to change the length or diameter of our pipe in the water analogy. Since all materials have some sort of resistance, another fun activity you can do at home is measuring the resistance of your skin. Believe it or not, your skin is very resistive, but variables like how much you're sweating can change its resistance. This is how novelty lie detectors work, by measuring the resistance of your skin and how sweaty you are from being nervous. So use 2 test leads of a multimeter on your friend's hand and ask them a question. If the resistance goes down, they're lying. Thank you for watching. Remember to like and subscribe.